Hello and welcome to this video about the art of problem solving. This video is being made as a prep for the AMC08 test. And so what I want to do is just take some time and talk about some strategies to help you problem solve. Because what you're going to see on the AMC08 test is some unconventional problems and ones that kind of make you think outside the box and ones that don't have answers that are readily apparent. And so I'm hoping that this video will help prepare you for that. So first of all, let's just talk about some conventional wisdom, and then I'd like to add on my own advice. So conventional wisdom, there's a lot of strategies out there for problem solving, but I just want to highlight three big ones. So the first one I'm going to call flailing. And flailing is this sort of guess and check method where you're just kind of trying to, see what happens. And part of flailing might be, doing a simpler problem. So trying something maybe simple. So you look at the problem, you try to maybe boil it down to its essence, and then you see what happens, and then you try to look back at the situation and see what's going on. Flailing might also mean doing something like using small numbers. Depends on the situation that you have, but maybe, see what happens if you put in 0, 1, or 2. And so that might help you with kind of realizing what's going on with the problem. So flailing, it's not the most elegant form, but it's just kind of this guess and check, kind of seeing what's happening, and you're just going to see what you can get from the problem by trying it, because it's kind of goes with that adage that failure, teaches you what not to do. And so you're just kind of flailing around. You're putting numbers in, you're trying this, you're trying that, and it might work and it might not, but if it doesn't work, you now know that it doesn't work like that, and you can try again with something else. The second one is someone that I like. Draw it out. Especially for problems that might be related to geometry, drawing it out really, really helps. And then the final strategy I want to talk about is making lists or tables. And the reason why I really like this is it helps identify, let's learn how to spell here, identify patterns. So making a list or a table, it can help us sort information so we can then figure out how to use it, but at the same time, it might help us identify a few patterns. So these are three main strategies I think everyone should have in their back pocket as they approach something like the AMC08, or they ever find themselves having to do some, maybe outside the box math, have to do some problem solving there. Got flailing, draw it out, making lists and tables. Now, briefly, I'd like to throw in my own 2 cents here. And this comes mostly from my experience, so let me just write that down. My advice from what I'm seeing with students. The first one is an odd one. You wouldn't necessarily think you'd have to say this in a math class or have to, talk about this in a math class, but when dealing with word problems especially, read, read, read. I can't stress that enough. Often these really complicated word problems are constructed in a way that you're not going to get the answer immediately. You need to keep reading it, because each time you read it, you're going to, approach it from a different angle. You're going to get a different piece of information, and you're slowly going to piece it together. So just keep on reading, and you'd be amazed how that might help you. Second, have pencil meet paper. I can't stress that one enough either. You need to have your pencil meet paper. Start doing something, see what happens. You never know what it might lead you to doing. All right, so with that being said, let's take a look at a couple of examples so we can kind of see how some of these strategies come into play. I want to start off with this one. Now, these examples I have here, they come from one of my favorite Problem of the Week resources, and this the difficulty here is for 9th to 10th graders. So kind of pushing what you would see on the AMC08. However, a lot of it relies on kind of combining a lot of middle school skills. And so let's just kind of, glean what we can from this. And also I'm hoping to maybe inspire you to ask questions about like, what is an isosceles triangle? Can you tell me a little bit more about that? So I'm just going to kind of gloss over some of the details. I'm more showing, this problem-solving tactics that we could use. And again, if you're inspired to ask questions, please email me, let me know so I can help you. So let's look at our first problem. In the diagram, we're told that angle XPY, which is this angle right here, is 15 degrees. Points QRST alternate from one arm of the angle to the other, each point located further away from P than the point before. However, if PQ equals QR equals RS equals RT, so on and so forth, what is the maximum number of isosceles triangles with equal side lengths of length PQ that can be formed? This is a problem where pencil just needs to meet paper. So what I'm going to do is I'm going to redraw it to make it a little bit easier because we're going to need a lot of space here. So we were told this is 15 degrees. And that what we have here is a series of isosceles triangles. Now, a property of isosceles triangles is that they have congruent angles. So we know that this also has to be 15 degrees. And then we have this going on right here. What we can do now is to kind of play a supplementary angle game and an isosceles triangle game. So we have 15, 15. That's a total of 30 degrees. A triangle is supposed to have 180. That leaves us with this being 150. This means that, so as a result, this angle has to be 30, and that one has to be 30. And now we have 30, 30, which is 60, and this whole thing has to add up to 180. So we now get 120. We have 15 plus 120 plus something needs to equal 180. And that's how we can figure out what this next angle is. So let's draw another triangle, figure out what that angle is. So let's see here. 180 minus 120 is 60, minus 15 would give us 45, which means that this needs to be 45, and therefore this will need to be 90 degrees. And then let's see here, we have 30, 90, that's 120, meaning that this next one would have to be 60 degrees, and then that's 60 degrees, and then that's 60 degrees. And so far we have one, oops, maybe I should do it in that color. We have 1, 2, 3 triangles. And let's see if we can get any more. So again, if this is, or let's see here, what can we do? Here, we know that that's 60 degrees, and so that means that this would have to be 120, well, that's probably not going to be 120 degrees. Okay, so let's get rid of that. But let's see here, so we have 45, oops, undo that. We have, there we go, 45 and 60. So now 45 plus 60 plus something has to equal 180. So that's what, 105. And then we go 180 minus 105. That gives us 75, 75. And now that has to be 30. All right, and so what we're getting from this is, so far that's 90, that has to be 90, and uh-oh, we ran out of triangles. Because, this would have to be 90, and then that means that this would have to be 0. We can't make any more isosceles triangles. And all we've been doing is just pencil meeting paper, counting it out. And so now we need to count them all up, and I realized I miscounted earlier. So let's see, this one doesn't actually exist, so we'll scratch that one out. We have 1, 2, 3, 4, 5. So we get 5 triangles from this problem. And I haven't done any real fancy math. All I've done is grind it out. And I just kind of started pencil meet paper, doing something with, some triangle angle sums, knowing I have to add 180, knowing that straight lines have to be 180, and I just went as far as I could. So that's one great strategy. Now let's look at another problem. And I love this problem because it's prime for a table. So the way it works, we have the digits 1, 2, 3, 4, and 5, and they're each used once to create a 5-digit number, A, B, D, or B, C, D, E. And they have to satisfy these conditions. ABC has to be odd, BDE has to be divisible by 5, and CDE needs to be divisible by 3. And so what I think would work out great is if we made a table, A, B, C, D, E, and we look at the possibilities. And so let's start off with some of the things we're known. In step number 1, or in condition number 1, ABC has to be odd. So what that means is that C has to be 1, 3, or 5. Now we go to condition number 2. The 3-digit number BCD is divisible by 5. Well, numbers are only divisible by 5 if they end in 0 or 5. 0 is not an option, so that means the only possibility for D is that it has to end in 5. And that means that 5 cannot be CDs. Next, we'll look at this condition right here. The 3-digit number CDE is divisible by 3. Well, if something's divisible by 3, the sum of its digits have to be a multiple of 3. And so what I'm seeing is 1 plus 5 is 6. And the only other way I'm going to get a multiple of 3 is by adding 3. Now I could, let's see here, go with, let's see here, so, yeah. Sorry, 6, so 3 is the only one that would work for that. But if I do 3 and 5, so like if, let's use some colors here, has to go like that. But if I go with 3 and 5, because we don't know what C could be, that gives me 8, and then it could be 1, or I have another option, 3, 5, and 4, because 3 plus 5 is 8, plus 4 is 12. 3 plus 5 plus 1 is 9. Those 3 digits are divisible by 3. And so what that does is it leaves me with a few options for what A and B can be. So A can be 2, and then B has to be 4. Or A could be 4, and B can be 2. Except if I'm using 4 over here. And so if that's the case, I have 1 still available. And so let's, first of all, we'll address that in a second, but let's just sort of write out some of the numbers that we have. So I have 2, 4, 1, 5, 3. Then I can flop the order of the 2 and the 4, essentially use this one right here, to get 4, 2, 1, 5, 3. But then I also said that I could go with 3, 5, 1. So I can essentially flip these guys. So I have to rewrite 2, 4, 3, 5, 1, 2, 4, 3, oops, not 2, 4, 4, 2, sorry. 4, 2, 3, 5, 1. But then I was like, wait a minute. I do have a special case where 4 could be at the end. And if 4 is at the end, it can't be at A or B. However, 1 could go here. So I could have a 1 here, and then a 2 there, or I can have a 2 and a 1. And so that gives me just a few more numbers. So I'll go back to red. I could go with 1, 2, so 1, 2, and then I'm going to go with 3, 5, 4, or 2, 1, 3, 5, 4. And now I've exhausted all my options. And so to answer this question, I have 6. But the key to opening up this question was a table, because the table helped me sort out the information and organize things. So for example, like, C has to be an odd number, But then when I get to that second condition, I realize that 5 has to go here. Therefore, 5 cannot be in C. And so it's allowing me to eliminate some possibilities. And then I start playing with 1, 5, and then what can I add to make it a multiple or a number that's divisible by 3? That would have to be 3. But then if I flop it around to 3, I have a couple other options, and it's just kind of helping me organize everything. Finally, let's look at this problem. This one is a great example of using a table to help you organize and maybe make a pattern. So the power 7 to the power 7 to the 5th equals 16,807 when expressed as an integer, and its last two digits are 0, 7. I think that's crucial right there. Last two digits. Like, why would they say that? That's really weird. So there might be a purpose for that later. What is, essentially the question is, what is 7 to the 2015 as an integer, and what are the last two digits of that? Well, I don't think you can just type in 7 to the 2015 and get an answer. So what we need to do is maybe see if we can find a pattern. So let's make a table. Let's have our exponent, and then we'll have 7 to the x. So when I let the exponent be 0, we'll start at 0. Again, we want to start with nice, easy, small numbers. I end up getting 1. Then let's go with the first power. That gives me 7. Let's go to the second power. Let's go to, that gives me 49. The third power gives me 343. And then after that, I have to do a little bit of scratch work to kind of figure out what the fourth power is. But when I do that, I end up getting 2,401. And then I know the fifth power is going to be 16,807. And then just for good measure, I'll do one more here. I'll go to the sixth power, and that gives me 117,649. Okay, that's 807. Let's make sure that's clear. All right, now I want to focus on the last two digits. So I'm also going to backfill a couple of these. I'm going to put a 01 and a 07 there. And I want to see what's going on. And what I notice is that there's a pattern. 01, 07, 49, 43, 01, 07, 49. And so I'm not going to actually figure out what it to the seventh power is, but I'm going to imagine that it's going to end in 43 as the last two digits. And so I've picked up on a pattern. Every four, there are four possibilities here. And so what I have to do is figure out where 2015 comes into play there. And so I have a couple of options that I could go with here. I know that 2015 is really close to 2016. So let's let me do that. 2016. 2016 is a multiple of 4. And like I said, every four of these has a pattern. In fact, the fourth one, anything that's a multiple of 4, would end in 01. And so yeah, 2016 is equal to 4 times 504. Now, it doesn't really matter what this is, because what this is telling me is that it's going to have to be something that matches up with a 4. So let's see here, 4 ended in 01, and then if I follow my pattern, 8, well, we have, 4, 3 preceded it, so it's going to be 01. So 2015 comes right before 2016, and so that means that the last two digits of 7 to the 2015th will be, so let's see here, last two digits will have to be the one that precedes some sort of multiple of 4, which would be the 300, or which would be 43. So 43. Now again, the problem, you look at it, seems kind of tricky. However, you use a table and you can make a pattern from it, and from that pattern you can really crack it open. And so this is the goal of the video, to kind of show you some different math, to show you some exponents, to show you a little bit of geometry, to show you just some number theory, and how some of these problems that don't actually have very complicated concepts in them can be respun in a way that seems complicated. But if you have the right tools, you can crack them open. You can work with them. And so make tables, organize your information, look for patterns, draw it out. Just have pencil meet paper and good things can happen. So hopefully this is equipping you with some skills you need for the AMC8. Let me know if you have any questions. I'm more than happy to help you with them.